Oh, we're going to do stick work first. Sorry, I probably shouldn't put that chair out.
I thought you wanted me to sit down.
No, that's true, I did. Good morning, everybody. Okay, we're going to start with a little stick work here in a minute just to get our blood moving a little bit. But what we're going to watch today are two relatively short videos, both with James Lovelock. The first video focuses a little bit more on the nuts and bolts of the mechanism of how the Gaia hypothesis works. A scientific theory is no good if there's no mechanism. It's just an idea until you have the mechanism. When you've got the mechanism, then you've got something that will make some predictions and that you can actually critique in a scientific way. It can be faulty. So today we're going to watch two videos with James Lovelock. The first one looks at the Gaia theory in a little more detail than we looked at it before, and it's going to focus a little bit more on the mechanisms. It's not super deep, but at least gives you the idea of how something like this actually works in the real world. And what it has to do with, essentially, it is cybernetics. It's positive and negative feedback systems and how they interact. Do you know where the word cybernetic comes from?
No.
It comes from the ancient Greek, and what it meant was the person who steers a boat.
Those Greeks.
Those ancient Greeks, they were so clever,
Gracious.
right? So cybernaut is someone who's got hold of the big tiller on an ancient Greek thing. Anyway, so we're going to look at that one, and then we're going to look at another one, which is just sort of a general interview, but it gives Lovelock a little bit of a chance, anyway, to say some things about where he thinks the world is and where he thinks the world is going to go. Again, not super deep, but it at least gives you a chance to start on that thinking. So the whole video is about 50 minutes long or so, and then we'll have a short discussion afterward. And then in the next session, we'll be doing a little Tai Chi. Okay, we are moving into the final 3 sessions of the Earth Body, Your Body series. In this session today, March 8th, we're going to look at 2 more videos of James Lovelock, the creator of the Gaia theory. In the first video, we'll look a little more deeply into the nuts and bolts of how the theory actually works. And in the second video, we'll watch an interview with Lovelock where he looks into the probable futures for both the Earth and for humanity. In 2 weeks, on Saturday, March 22nd, we'll be watching a video interview with ecologist Dr. Bill Reese on ecological overshoot, that is, on the situation when the demands made by humanity exceed what the biosphere of the Earth can provide. And then finally, in the last session on Saturday, March 29th, we'll have a discussion about our current situation and the possibilities for the future. Some of you have already pointed out that we're edging into territory that is quite serious and potentially troubling. That is true. There is no denying that we face a serious situation. There is no denying that the outlook, both for the Earth and for humanity, is troubling. In this situation, I think we can do no better than to remember Tolkien's exhortation to King Theoden in The Lord of the Rings. Take courage, Lord of the Mark, for better help you will not find.
I see the Earth as more than just a mixture of living things and inanimate matter. I see it as a tightly coupled entity where the evolution of the living things and the evolution of the inorganic matter constitute a single and totally inseparable process. It's a whole system. Somehow or other, life appeared on Earth. I don't give a damn if it was somebody put it here, whether it was a waste bin cast aside by some visiting spacecraft, or whether God fiddled around with the chemicals and started it, or whether it dropped out from space, as Fred Hoyle would have us believe.
Okay, so I want to make a comment here. This particular video was made, I believe, in the late 90s. So a lot of work has been done since then, but you can tell from what he just said about the origin of life that it was a question that was still very much up in the scientific world. It still is. However, a lot of work has been done and a lot of very detailed theories have been put forward. We watched one of them a couple of weeks ago with Eric Smith talking about what is called the metabolic theory. So take into account, because this is interesting, with these two videos. This video was made in like the mid-90s. The next video was made in, I believe, 2005. So these are, you're actually looking a little bit into the past here when you're watching these. And if you pay attention, you will notice that our understanding of things has progressed a little bit from here. And that's an interesting thing to note. Okay, hold on.
Somehow or other, it started here. At that time, the Earth must have been just right for life, otherwise it wouldn't have survived. But the Earth was evolving geochemically and quite remorselessly towards, although it would take a long time, a state like Mars or Venus, and utterly impossible for life. So life arrived just at the right moment, so to speak. Gaia is the name that I give to the system that is the Earth. It's also the name of the theory of the Earth as a system, which is, I suppose, saying the same thing in other words. Gaia got its name in the oddest of ways. Many years ago, I used to live in a village called Bowerchalk in southern Wiltshire, and a near neighbour of mine was that novelist William Golding, and he and I were good friends, and we used to go for walks around the village talking about philosophical things and that. And when the idea of Gaia came into my mind, I didn't call it Gaia then, of course, I was telling him about it, how I thought the Earth was a self-regulating system and that the organisms somehow were involved in this process of self-regulation. And he rather liked the idea, and he said to me, well, you better give it a proper name. So I said, what do you suggest? He said, I'd call it Gaia. And for 20 minutes we walked on. I was very puzzled because I thought he'd said the word G-Y-R-E, those great whirls that go round and round in the ocean. And I could see that it was a circular thought that I had in my mind. But I thought Gaia was going a bit far. And then he suddenly said, no, I meant G-A-I-A, Gaia, the Greek name for the Earth goddess. And of course that I accepted.
So, how did it all begin? In the early 1960s, Jim Lovelock worked for NASA, which steadily grew obsessed with the search for life on Mars. 10 years before the Viking landings in 1976, Jim pointed out that life on Mars would have left its signature in the composition of the Martian atmosphere, and that evidence for such a signature was singularly lacking. The relationship between atmospheric composition and life on Earth led to the first detailed formulation of the Gaia hypothesis. It soon became controversial.
The old Gaia hypothesis, as it was first stated, arose like this. What I'd found was that looking at the Earth in the Mars business and discovering this wonderful atmosphere with all of these gases out of equilibrium and yet somehow keeping constant, I knew there was something that was regulating it. And it was natural for me to think that it was life that was doing the regulating, and that it was doing it in such a way as to keep the Earth comfortable for itself. I think few would have come upon it differently when confronted with the evidence that I had then. And so the next few years I went chunnering around looking for evidence that would support this notion that life was regulating the planet and keeping it comfortable for itself. And I was brought up short and sharp by Richard Dawkins and Ford Doolittle's comments that there was just no way that life could regulate anything beyond its phenotype, and this was all nonsense. And this led to the development of the Daisy World model, which showed how, in fact, it wasn't life, but the whole system of life tightly coupled with the physics and chemistry of the planet, with its environment, that did the regulating, with regulating being an emergent property of this tightly coupled system, not something that required purpose or foresight on the part of the organisms. And I think this definitively answered Richard Dawkins' criticism. I think, as another biologist put it even more forcefully than Richard Dawkins, if Gaia is to be real, it would require a trades union of the species of organisms to meet annually on Mount Ararat and negotiate next year's climate, which is clearly absurd. Now, Daisy World was a model that was made to show that the evolution by natural selection, using all of the selfish gene ideas that Richard Dawkins espouses, could, quite naturally, if you coupled the evolution of the organisms tightly with the evolution of their material world, produce a system that was self-regulating. No purpose, no foresight, no planning was needed. Now, the details of Daisy World are like this. I want you to imagine a model planet just like the Earth, orbiting...
Daisy World is a simple planet. Like the Earth, it orbits a star, which, like our Sun, is getting progressively hotter with age. Unlike Earth, Daisy World has a very simple atmosphere, with no greenhouse gases like carbon dioxide to warm it up. And it only has two sets of inhabitants: black daisies and white daisies. The black daisies absorb incoming solar radiation, so they warm up. And as they warm up, they radiate heat, warming up their surrounding area. The white daisies, on the other hand, reflect the sunlight and stay cool. For both colours of daisies, 22.5 Celsius is the optimum temperature for growth. Now let's see what happens throughout the life cycle of Daisy World as things warm up. At first, Daisy World's young sun is cool and the planet is rather cold. And the heat-absorbing black daisies are at an advantage.
Consequently, by natural selection, dark daisies will be favoured, and at the end of the first season there will be many more dark daisy seeds left than light-coloured ones. So at the start of the next season, dark daisies will be off to a head start and soon will be spreading, warming not just themselves but their immediate locality. And then, with explosive, positive feedback, dark daisies will spread right across the planet and warm it right up to temperatures close to those comfortable for the growth of daisies.
The black daisies proliferate and slowly spread out from the warmer equatorial regions until they cover most of Daisy World, turning it black. So Daisy World can absorb heat and warm up. As the temperature gets nearer the 22.5 Celsius optimum for all daisies, life gets easier for the white daisies, who then prosper. At first, they grow best at the warm equator. Then they slowly move out, finding a niche alongside the black daisies. But in areas of high solar radiation, the white daisies do best as they cool their environment. Whereas in areas of low solar radiation, black daisies predominate by warming their environment. In all areas, the numbers of black compared to white daisies depends on the proportion of heating or cooling necessary to maintain the optimum growth temperature.
I have no doubt that by far the most important thing to come from Daisy World was the mechanism that it offered to explain how the Earth regulates its temperature. You see, Gaia was not acceptable to most scientists, geochemists, biologists, or anybody else, without a mechanism that explained how it could work. It seemed to them just pure moonshine, nothing solid about it. It was rather like plate tectonics, the theory of vagueness theory. Until a mechanism was available, nobody could believe there was anything in it. And the same was true for Gaia. And Daisy World gave just that mechanism.
I wanted to make a comment about his comment on Wegener. I remember being back in the 5th grade and looking at the big map of the world in the front of the classroom and realizing or thinking that the shape of the east coast of South America fit perfectly into the west coast of Africa, and kind of wondering why those things would be so remarkably similar. Well, in fact, that was just prior to the acceptance of plate tectonics and continental drift. But that's a theory that a German geologist named Wegener put forward in 1912. The problem was there was no apparent mechanism that would allow something like continental drift to happen. The basic theory back then was continents were stable. They didn't move around. Nobody even thought about that. But Wegener did think about it because he looked at it the same way I looked at it as a little kid. And he spent a lot of years researching and realizing that, let's say you take the continent of South America and Africa and put them together, there ought to be geological structures common to both continents that would match up like a jigsaw puzzle. In addition, there ought to be fossils, very ancient fossils, that also match up like a jigsaw puzzle. So he spent decades going around the world looking into those ideas, and he found them. So a geological structure in Brazil would match up with a geological structure in North Central Africa. The same with fossils. But there was no explanation about how any of that could possibly be true, because there was an Atlantic Ocean in between them. But after World War II, or actually during World War II, we began to study the ocean bottom. Now, the Department of Defense was doing that in order to understand the ocean for submarine warfare. But that was when they found the mid-ocean ridge, which was coming up from inside the Earth and then spreading out both east and west at about a couple of centimeters a year. And that gave the mechanism that proved that Wegener's 1912 theory was in fact correct. And in the mid-60s, then plate tectonics and continental drift became the new thing that everybody was excited about. And of course, what Lovelock is saying is exactly the same thing has been happening for the Gaia theory.
But Daisy World's sun is still getting hotter, and soon the black daisies find it hard to cope, whilst the white ones stay cool. The white flowers soon outnumber the black ones, and Daisy World becomes whiter and whiter. The white planet can reflect the increasing solar radiation and stay cool, but the sun gets hotter still. Eventually, the planet gets too hot, and even the white daisies can't cope. Daisy World dies.
In a way, Daisy World resembles a living organism. I know biologists hate me for suggesting such a thing, but it does, and perhaps the way in which it most resembles it is that it can die. If the sun gets too hot for Daisy, the star gets too hot for Daisy World, then even a total cover with light-coloured daisies is insufficient to keep the planet cool enough for them to survive. And at the moment some of them start dying, darker bare ground is exposed, and then again, with explosive positive feedback, the temperature zooms upwards, far beyond the range of toleration of any kind of life, so it dies.
22.5 Celsius is the optimum growth temperature for both black and white daisies. The black daisies work with the sun and warm the planet. We call this positive feedback. White daisies work against the sun and cool the planet. We call this negative feedback. In Daisy World, we're concerned with the combined effects of both positive and negative feedback. This graph represents the temperature of Daisy World based on changes in solar luminosity alone, without the influence of the daisies. If we now add the daisies, we get this curve, which shows both positive feedback from the black daisies and negative feedback from the white ones. Together, they regulate the planet's temperature, producing a stable environment despite the changes in solar radiation.
I see Gaia theory as a theory of evolution in which in no way discards Darwin's great vision, but includes also the geological evolution of the Earth and couples the two together tightly. What emerges from the synthesis of these two older systems are such properties as self-regulation, that's to say, the regulation of the climate and the chemical composition of the Earth so that it is always a fit place for life.
The Daisy World model is a very general one, and you can play all manner of games with it. So let's make it more realistic by giving the daisies a few problems. For example, we could introduce rabbits to feed on the daisies. At first, the rabbits would try to eat up all the daisies, but as the daisies became scarcer, the rabbits would starve. So the rabbit population would decline as a result. If then the daisy population recovers, this will be followed by a recovery in the rabbit population. This is another example of a positive and negative feedback system which balances out over time. So if the rabbit population fluctuates like this, the daisies correspond like this. During the population cycles, there appear to be runaway increases or decreases in the number of rabbits or daisies. But when measured over a long time, a balance or equilibrium has been achieved between the number of daisies growing and the number of rabbits supported by them. This balance means that the rabbits have little effect on the long-term well-being of Daisy World. The same long-term balance will eventually be achieved even if we introduce further biological perturbations. We could, for instance, introduce foxes to prey on the rabbits, or a plague to kill off a high percentage of the daisies, or competition between daisies of different colours, or whatever perturbations we may care to invent.
Biologist critics in the early days suggested that if there appeared on Daisy World a grey-coloured daisy that didn't use energy making light or dark pigment, it would have an advantage and would take over the whole scene and regulation would collapse. They call this a cheat. I took them seriously, and I made a Daisy World model in which a grey-coloured daisy was included. And to make things harder for the black and white ones, I taxed them 5% of their growth rate for making pigment. It was most instructive when the model was run. The dark and light-coloured daisies flourished just as before. The grey ones flourished as well, although interestingly not quite so well as the dark and light ones. You see, it's really quite simple. When it's very cold, only dark daisies are fit to grow. Light and grey ones cannot. When it's very hot, only light daisies are fit to grow. The dark and grey ones cannot. So the grey daisies have their place.
The effect of feedback is a zone of quite remarkable planetary temperature stability in the face of quite massive changes in solar radiation. As the output of the sun varies, so the black and white daisies simply respond to changing conditions. But in doing so, they regulate the temperature. The process is entirely automatic. It's just an emergent property of the system.
The most important conclusion I would draw from Daisy World modelling is that it demonstrates that a system such as Daisy World can self-regulate without there being any purpose, foresight or planning or anything built into the system beforehand that would make it do so. The other most important thing I would single out from it, which I'd add on to that, is that Daisy World is the mathematical basis of Gaia theory and the explanation of everything that I mean by Gaia.
This is the second video.
I see the apparent constancy of temperature on Earth throughout geological time, knowing that it is almost certain that the sun has warmed up by something like 30% during that interval, which is a huge increase in output from the sun and enough to change the climate drastically. If it was freezing at the beginning, it should be well on the way to boiling now. If it was comfortable at the beginning, well, the way up. So yes, it is one of the most solid pieces of evidence for a self-regulating system like Gaia being present on the planet.
Lovelock now sees that the average temperature range that the planet self-regulates to is far more complex than he originally thought. For example, marine algae grow best in the laboratory at 20 Celsius, but in the oceans are limited to 8 Celsius or below. Water mixing ensures a supply of nutrients and the algae flourish. Huge algal blooms can occur, as this satellite picture shows, even though the temperature of the water is 10 Celsius below the optimum growth temperature for the same algae in the laboratory.
So this shows that it isn't just the needs of the organisms that determines the temperature of self-regulation, but the needs of the whole system. The geophysics and the needs of the organisms can tightly couple together as a single system.
Another way of evaluating a theory, like the Gaia system theory, is to see how useful it is at making predictions.
I suppose the first of them is a strange one because it happened before what was at that stage no more than the idea of Gaia existed. And here I refer to the prediction that Mars was probably lifeless. It was a prediction that was confirmed by the Viking lander, which found there was no life on Mars. Because if you go back to the evidence I've already talked about here, you will see it comes from the assumption that the Earth is a system which has an atmosphere which is self-regulating in the way that I've described. And using that evidence, Mars has an equilibrium atmosphere and therefore should not have life. So that was perhaps the first one. The next one, and perhaps important one, is the prediction that chemical rock weathering would be modulated by the presence of living organisms at the Earth's surface, so that their response to temperature change would, so to speak, control the rate at which weathering took place, and therefore the level of carbon dioxide in the atmosphere, and thence climate. That was the second. Now the third is a double one. It was well known that sulfur is in short supply on the land, and it is washed off by rain and taken down the rivers into the sea. And I thought there must be some biological process that would convey an element like sulfur back from the sea to the land. I know that the algae growing in the ocean produced dimethyl sulfide because in 1972 I sailed in a ship from Barry in Wales down to Antarctica and back and measured the production of the strange gas all the way that the ship travelled and everywhere in the ocean that it went. And Peter Liss at the University of East Anglia examined the data and calculated from it what will be the flux of dimethyl sulfide from the ocean to the air. And interestingly, it was just the quantity needed to balance the budget of the sulfur cycle. So, in a sense, this was the first experimental confirmation of a Gaian prediction that there would be element cycling in just the right quantity to sustain biological needs. Now, this story didn't end there. In 1986, I spent a short while at the University of Washington at Seattle in the department of Robert Charleston, the meteorologist. And we got to discussing clouds and how they formed. And Robert told me about this business that clouds require condensation nuclei, otherwise they cannot form over the oceans. Of course, instantly it occurred to me that the dimethyl sulfide could oxidize all too readily in the air and be the source of just these nuclei that he sought. And we got together with Andy Andre and another meteorologist, Stephen Warren, and produced a paper which was published in 1987. This paper hit science like a storm, and I would think there must have been at least hundreds, if not thousands, of papers have followed and investigations around the world subsequent to it. And I was very pleased that Robert Charleston at the Oxford meeting on Gaia in April 1994 fully acknowledged this fact that but for Gaia thinking we would never have developed this notion of the algae in the ocean being connected with the clouds and the climate. So that is perhaps the third prediction to come from the theory. The best way to test a theory is to get it to make what I think that famous philosopher Karl Popper called risky predictions, and then go out into the world and see if these predictions can be falsified or justified. He prefers falsified, because if it's falsifiable, then you throw the theory out. It's never quite as simple as that. In practice, we scientists modify our theories if we find them falsified rather than throw them away. It's just as well we do. We strictly adhere to Popper. Darwin would never have set sail on the Beagle. And where would we be then?
Sorry, this is the actual second video here.
When I first thought of the Earth as a self-regulating system, it was in 1965, over 40 years ago, and it slowly evolved in my mind over the next couple of years or so. And I used to live in those days in Wiltshire, in the village of Bowerchalk. And a near neighbour of mine was the famous novelist William Golding, who subsequently got a Nobel Prize for his writing. And he was a close friend of mine, and we used to often to walk to the village shop to get things or post our letters. It was also the post office. And he would quiz me about what I was doing in science, because he was very interested in science, although he was a literary man. And I told him about this idea of a self-regulating Earth, and he said, well, you better give it a proper name. Too big a theory just to be some scientific acronym or something like that. So I suggest you call it Gaia. Since I introduced the concept of Gaia, it's gradually become mainstream science. They never talk about it as Gaia because the biologists scorned it so fiercely in the early days that most scientists are scared of using the word. So they talk about Earth system science, but it's the same thing. And we now realise that the Earth does regulate itself, and we know quite a bit about all the various systems. You see, it's a good theory. It's made no less than 10 predictions that have come true, and that's good going for any theory. For example, we now know through Gaia theory that the clouds over the great ocean areas of the Earth are produced by organisms living in the surface, the algae. They produce gases that go up into the air, oxidize, and produce the nuclei around which cloud droplets form and reflect sunlight back to space. The Earth would be perhaps 10 degrees hotter were it not for the existence of those clouds and the organisms that produce them. We also know that the removal of carbon dioxide from the air would not take place at anything like as fast as it does were it not for the organisms present in the soil and on the rocks and everywhere around the Earth and in the ocean as well. And those twin processes, reflection of sunlight and pumping down of carbon dioxide, are what keeps the Earth regulated. If there were no life on Earth, and this is such an easy calculation, you can practically do it on the back of an envelope, you would find that the Earth's temperature would be well over 60 degrees Celsius throughout. I have no personal doubts about the validity of global warming. There are not only are there specific events, odd events, that have happened so rarely in the past that they're extraordinary, but there's a concatenation of them, one after another happening, that the man in the street notices. Ask almost anybody if they think the climate's changed in the last couple of decades, and they'll all say yes, and give you lots of examples of why. I mean, just think of here where I'm living. People are talking about growing olives in Devonshire. Would you believe it? Wine is grown all over the place now. There's even vintage British wines. It's the whole thing is changing, and changing in a way that the man in the street notices. However, to add to that, we're nearly all urban now, and we live in air-conditioned houses and cars and so on. And we don't see anything as much of the environment as our ancestors did. Well, and because of that, we've lost touch with the natural world and are unaware of the changes that happen in it. Global warming is much more than just a real effect. It's something deadly that'll threaten nearly all of us who are now alive on the Earth by the end of this century. The climate right now, if we'd never developed as an intelligent species, would be probably moving slowly back towards the next glaciation. There's some debate about that. Some think the present interglacial would have gone on a bit longer this time, perhaps as long as 50,000 years. But sooner or later we'd have gone back into an ice age again. Now we will not. By putting all that much carbon in the atmosphere, we've irreversibly changed the Earth so that it won't go back to another ice age, not at least for another 200,000 years. The climate change we're seeing now is closely similar to a geological event that occurred 55 million years ago at the beginning of the period the geologists refer to as the Eocene. What happened then was, we're not quite certain how, but something like 2 million tons of carbon dioxide came into the Earth's atmosphere over a period of about 10,000 years. And I think the most likely cause was a volcanic sill, lava underground from a volcano coming up beneath a petroleum deposit which was in what is now the Norwegian Sea. And this vaporized practically the whole of the deposit and put this huge quantity of carbon into our atmosphere. Well, when you ask about 20 to 30 years ahead, I can speak not just from my own view, but from the expressed opinions of senior climatologists who have represented their thoughts in the Intergovernmental Panel on Climate Change's great reports. The most recent was in 2001, but one is due next year, the update, and I've seen it. And what it says is this, quite simply, and it's very stark, that by something like 2040 to 2050, the European excessive summer of 2003, when over 20,000 people died of overheating, will be the norm. Every year will be as hot as that, nearly. Now, the consequences...
I should make a comment here. A lot of people in the United States don't realize, but the climate in Europe has been changing pretty radically for the past 30 or 40 years. And what's essentially happening is that the climate of North Africa, that is, of the Sahara Desert, is slowly moving north, so that the southern parts of Europe, Sicily, southern Italy, southern Spain, southern Greece, are becoming quite arid. And it's gradually moving north. Now, he's going to mention they're starting to raise not only grapes, but even olives in Great Britain, which used to be a rather cold northern country.
For people might be dealt with. They may go away for the summer to cooler places, or they can turn up the air conditioning. But for the plants and the ecosystems, there's no such relief. And the probability is that European agriculture will cease to produce food by then. It'll become a desert and scrub region naturally. That's not very far ahead. So where do the European people get their food? Because the rest of the world will not be exempt. Asia, America will all be suffering the same consequences, as will Africa and the other nations of the southern hemisphere. We will be entering a world where supplies of food becomes more and more scarce, and there will be mass migrations. Anyone with an imagination can see the awful human consequences of that, and we're talking about something which is only about 30 years ahead. If we follow the 55 million years ago precedent, temperature rise will now be leveling off as the Earth system, what I call Gaia, takes control. Just like when one of us gets a fever, our temperature doesn't go up until we become roast meat. It levels off at a higher level and after a while sinks back again. Same's true of the Earth. Many times in the past, when there have been catastrophic events, that it's had a fever and its temperature has gone up, but never to totally destructive levels. We wouldn't be talking about it if it had. And so that's what I think will happen. It'll level off towards the end of the century at about 8 degrees warmer than it is now. That's a huge change.
When he says 8 degrees warmer, he means 8 degrees Celsius, which is about 15 degrees Fahrenheit, which is what we use in the United States. And that is an average. So what happens at the poles, what happens at the equator, what happens around the oceans is going to be huge variations.
It's looked at on a global basis, and it takes us to a region that humans have never experienced before. a state that it will be likely to last at least 100,000 years. I happen to think that there are too many people on the planet now. I think Malthus was right. You see, he wrote his famous treatise in 1800. At that time, there were only 1 billion people on Earth. And if his advice had been followed at that time, and all the great green ideas of sustainable development and renewable energy and so on had been applied then in 1800, we might have escaped the mess we're in now. Perhaps not all of it, but a great part of it. But we didn't. We went on increasing our numbers. I think that now 6 billion plus on Earth is quite unsustainable in any sense.
So this was made in 2005. There were 6 billion people on the Earth. Today there is a little bit over 8 billion people on the Earth, and we're heading toward 10 billion, although I doubt it actually gets there. It'll probably peak out somewhere around 9 billion.
Our giant mistake was combustion, learning to burn things. At first it was harmless just for cooking, but we never stop at that level. We start doing it on a grand scale, like burning down whole forests, because you get cooked meat a lot cheaper that way. It's much less effort. And that was our mistake. And we've been making the mistake for a long time, and we're only just beginning to discover how serious a mistake it was. Remember, it's not just modern man that's damaging the planet. The first people to move to Australia during one of the previous ice ages, a long time ago, managed to destroy almost the whole ecosystem of that continent with just quite simple tools, fire drive hunting and tricks of that kind. So we're a pretty unpleasant species in many respects, and always have been. Modern man is just more efficient at doing bad things. I think we are, as a consequence of global warming, going to have a major mass extinction of life on Earth. And if you include numbers, it'll be an extinction of humans too. I don't see more than, at the very best, 20% of us surviving through, maybe a lot less than that. And it's a very interesting question, because the event 55 million years ago was not a mass extinction. There was very little extinction of life, even though very much the same things happened. And the difference was that pollution of the atmosphere naturally took place over 10,000 years, and organisms had a chance to migrate to the cooler polar regions, where they survived throughout the 200,000 years of heat, and then they migrated back. We're doing it so rapidly that organisms don't have time to get up to those regions. They're not doing badly. It won't be a total extinction. It's quite surprising that the doubters of global warming will still comment on the fact, isn't it remarkable, I saw in my garden a hummingbird hawk moth last week. It must have flown up from Africa. Why? It's flown up because it's so much warmer here now. I think that the so-called alternative energy schemes like wind, solar power and so on are pretty inefficient and impractical, and no solution to our problems at the moment. And I think they're dreamt up by urban people who want to do something natural. They don't like anything industrial and feel that they're doing good. But they're not. That's not a way to run a country or a world. There are some what you might call natural power sources like hydroelectricity that are excellent. Why not use them? Norway largely runs on them. And if you've got hydroelectricity, use it. But the sad thing is we've used about all we can. There isn't any left to spare. One day maybe we can get energy from tidal sources. And I do wish the British government had had the sense to build the so-called Severn barrage. That's a power scheme across the estuary of the River Severn in western Britain that would provide the output of 4 major nuclear power stations. But there were too many arguments about doing it, and I'm afraid the Greens were the main objectors. They thought it would upset a wildfowl habitat somewhere or other, so it wasn't done. There is a nuclear power station not too far from here at a place called Hinkley Point in Somerset. I think our benighted government, over-influenced by Greens, may well let it shut down in, I think, even as soon as next year. If they do, it would require 3,200 giant turbines to replace it, and they would only work when the wind blew, which it doesn't very often. Hinkley Point has provided most of Devon, Cornwall and Somerset with electricity for the best part of 30 years without any problems whatsoever, so why close it? As a scientist, and one who when I was young read science fiction, that question, are we likely to be able to do anything about it by engineering or science, really fascinates me. And there are a lot of proposals up at the moment. Some colleagues of mine in NASA at Lawrence Livermore Laboratory have what seems a very reasonable scheme for putting up sunshades in space that would be at the gravity neutral point between the Earth and the Sun, so that it wouldn't take much effort to hold it there. And it would be a carbon fibre diaphragm spun out, I've forgotten the diameter, but quite large, 10 miles at least. And it's not impractical. They say it would cost less than the space station, but it would disperse about 2% of sunlight coming in and relieve us of global heating. Now that's one proposal. It would take a lot of time and a lot of politics to get it working, but it might happen. Another much more practical one is that we could mimic the great volcanoes. When Pinatubo went off in the 90s, it set back global warming for 5 years, stopped it happening, just because of the aerosol of tiny particles of sulfuric acid in the stratosphere reflected sunlight back to space. Now, Russian scientist Bodaiko suggested we do that as long ago as the 1970s. To alleviate global warming, but it wasn't taken up then. But it is beginning to get taken up now as a serious proposition. It would be quite easy to do. I would like to see it done by just getting the main airlines that fly commercially around the world to do the deposition of sulfur in the stratosphere as they fly. For example, if engineering allows them to burn sulfur-rich fuel, unrefined kerosene instead of the highly refined stuff, that would do it. That would put enough sulfur in the atmosphere to give you a Pinatubo every couple of years. It's all very well for wealthy urban people to say, but everybody ought to drive a hybrid or something small. But the average person can't suddenly go out and buy a new car. They're lucky to get their old banger going to and from work. There's a lot of impracticality here. It takes an awful long time. And how do you tell the Chinese to set back the aspirations of their people and stop building coal-fired power stations? They build one every 5 days, believe it or not. It's a very impractical suggestion to ask people to cut back on carbon sufficiently to have a big effect on the world in time. This is it. Time is the essence of everything. So I think those notions of amelioration, like sulfur in the stratosphere or sunshades, are worth pursuing because they will buy us time. But there's a big but. Think of them as like if your kidneys fail, you can always go on dialysis And who would refuse dialysis if death was the alternative? But it's only going to buy you time, that's all. When you ask the question, have we or when did we reach a tipping point in global heating, I think we've passed the point of no return myself, but it's only a speculation. I can't give you firm figures on it. Others think it will be a few years ahead, but whatever way you look at it, it's pretty close. We have to adapt. Adaptation is the thing humans have to do, and the thing they most have to remember is to try and preserve civilization. That's our most precious assets, and we're a huge benefit to the world that way. We tend to think of ourselves as some sort of plague or destructive agency. We are, but at the same time, we are something wonderful. After all those 3.5 billion years of evolution, the Earth at last has something with intelligence and communication, which is part of it, because we're part of it. We're natural. We shouldn't think of ourselves as separate from the Earth. And through our eyes, the Earth has seen for the very first time from space what an incredibly beautiful planet she is. And that's worthwhile. Well worth it.
Okay. Whew. I need to edit that second video a little bit. Honey, would you grab the microphone here? Yeah, that was about 10 minutes too long. Okay, well, we have a few minutes here, 10 minutes or so before the next class starts. So, any thoughts on anything? Kevin?
That was kind of interesting about his take on nuclear power. I think the problem that came up in my mind from my remembering all the hassle was that in cost-cutting measures, there was improper storage of nuclear waste, and it was leaking, and then people got panicked. And then the China syndrome came out, that movie where they talked about melting to the core of the earth and just scared people off. I mean, I've handled nuclear materials most of my career. In fact, I was in charge of disposing of the waste for several different companies I worked for in my division. And, you know, provided it went to the right place, it wasn't bad. One thing just I did read recently is that there's a way to detect radioactive disintegrations by using what they call photoscintillation. So the radiation hits this material, it makes a flash of light, and that produces energy. And we used to use that to count amounts of radioactivity in whatever we were doing. Well, now what they're doing is harnessing that to charge a battery. Mm-hmm. So instead of waiting for sunlight, you could have the nuclear waste power this collection to charge batteries to run run stuff. So you could utilize every piece of it. Seems to me a more interesting proposition. I mean, I have solar power on my house, and it has its limitations. I'm not sure I would do it again, but I have it now, and I'm not worried about it. But
yeah, well, you're in Oregon too, which is well known for having clouds and rain.
Yeah, agreed. Winter is kind of a zero-sum game.
Exactly, and at least in the old days, a lot of the year was winter. When Annie and I lived up here in Portland years ago, you could count on clouds and rain, certainly from usually about the middle of October, but let's just say November, all the way to next July. Yeah. So the July 4th holiday was really the holiday when the sun came out again. Everything before that, April, May, and June, it was still cloudy and raining all the time. Yeah. Now it's becoming, things are changing a little bit up here, but still. And that's really what Lovelock's point was about the solar and wind power. It's it's great under certain circumstances, but for instance, a country like Germany, Germany's a lot like Oregon. There's no sun, and there's not that much wind except right on the coast. So renewables sound great, but they just don't work for a place like that. So you've got two other choices, maybe three coming up now. You can go nuclear, you can keep burning fossil fuels, or maybe someday they're going to invent fusion. Now, Lovelock always said the day they invent fusion is the day the world's biosphere dies. Because give the human race unlimited energy and we will
We'll
screw
go crazy.
everything up.
And we
I-
know that because we have history.
We have history. This is we're running out of time here and need to go. So, but Genevieve, do you have any comments?
I think I think what I'm thinking about most right now is like the way that Lovelock speaks, these are like facts. And it's like indisputable at some level. And so I'm sitting here wondering like why that wouldn't be bigger news. Like if I polled my friends and colleagues, I don't think people would say within a few decades things will have changed that much that maybe 20% of our population will survive over the next X amount of time. It's like something that would be a headline, like the world is coming to an end, and I don't see that headline. So I'm kind of thinking about like the glacial speed of information processing in a world and like why this isn't more widely understood to be like what is actually going to happen. And because even when we speak about climate change, that still is in some circles, it's like treated as like a fringe belief.
Yeah.
So that it, I'm struggling to understand why this isn't more
Well, I
understood.
think it's very simple. It's just denial.
Yeah.
The people on the Titanic did not believe that ship could ever sink for a long time until it sank. So a lot of it is just denial.
It's inconvenient.
It's also very easy to misunderstand what Lovelock is saying by saying maybe only 20% of everybody will be left. That doesn't mean the other 80% are going to die in some great conflagration. Um, it just means that they're not going to be able to reproduce. If a country doesn't have enough food, yeah, it's possible starvation can happen. There's certainly been true in the past. But what it really does is depress the birth rate. And so you don't reproduce the larger population you have. The population just starts to shrink, and you see that happening everywhere around the world right now. However, Lovelock also used to say, people would ask him what's going to happen. He would say the population is going to be reduced, and it's going to be reduced by the four horsemen of the apocalypse. So famine, disease, war, death, right? And I'm afraid that he's probably right. One of the things that keeps niggling in the back of my head is, and I am not the first person to say this, but why does Trump want Canada and Greenland?
Because he has scientific reports.
Well, he's Trump is not stupid. He's crazy, but he's not stupid, and neither is Elon Musk. Years and years ago, I remember someone interviewer asking Lovelock, "Well, what will happen?" Well, the human population, he said at that time, would be reduced to about 5% of its present numbers. So if you take that as 10 billion people, we'd be reduced to about 500 million people who would be living on the land around the Arctic Circle. So what today is northern Canada, Greenland, and Siberia would become the new area where people would live. I don't know. But it would not surprise me a bit. Elon Musk wants to go to Mars. That is the stupidest idea I've ever heard. Mars is a dead equilibrium planet. You will never be able to
Bring it
terraform
to
it.
life, yeah.
So why does he want to go? What he says is, in order for humanity to survive, it must become a multiplanetary species. It would be very easy to think that Elon Musk sees the world getting into really big trouble, and what he wants to do is create his Martian colony as a kind of an ark. It's an ark for life to live until the trauma on Earth passes, and then we can come back and recolonize the Earth. It wouldn't surprise me a bit if that's what he thinks. Anyway, it's a good story. Okay, guys, I need 5 minutes to recombuberate myself before the next class starts. If you want to stay for Tai Chi, we're going to be working on finishing up move 3 and 4, maybe moving on to 5 too today. All right, so we will see you all shortly. Ciao.